Welcome, ladies and gentlemen. Just going to do a quick little recording here to kind of review what we've been talking about. I want to pick an element such as chromium. Chromium is element number, in this case, 24. So there's 24 electrons. We're going to do a couple of things. We're going to write the electron configuration. So one of the things we're going to want to do is we're going to want to look at a periodic table. And in that case, for our periodic table, it really doesn't matter which one you use, because all of them are pretty much in the same format. And in our case, for what we want to look at, there's all kinds of different kinds you can use. You might want to search for one that has the orbitals listed. So, for example, here's one I called up that says periodic table with orbitals. Now, you know, in this case, if I look for one on here, this is just lists orbitals. And if we come over here to this one kind of gives you them, and this will help you. You want to try to use one without them, because at some point you won't be able to see that portion. But for now, we'll go ahead and look at it this way. And like I say, really nothing else matters other than how many electrons when we're doing this. So I'm looking at chromium right here, element 24. So remember, they always, according to the Aufbau principle, they're going to load from lowest energy to highest energy. And it turns out that the periodic table is exactly in the order of the way they load if you read from left to right. So this is 1s, then 2s, then 2p, then 3s, then 3p, 4s, and then here's the first thing that was going to mess you up. Even though this is period 4, and the s's and the p's are 4s and 4p, the d's run one row behind, and that's 3d. So we're going to just go ahead and go back to our page, and we're going to, actually, let's just put it right in here. We've got plenty of room. So we'll just write that thing right in here, and when we do, we're going to look at the first configuration is going to be 1s2, and then 2s2 is going to come next. These top numbers are going to have to add up to that 24 for chromium. Then 2p comes next, and we can have 6 of those. And then 3s2, and then 3p6, 4s2, not 3d next. 4 is lower in energy than 3d. So it goes out of order a little bit, but that's okay. And then we're going to come to the d's, and we're going to count in to see how many, 1, 2, 3, 4 for the chromium. So we're going to call it 3d4. Now, we can draw the little boxes for this. So you can do boxes, you can do lines, you can do circles, you can do whatever you like. I'm going to do boxes, and every orbital that's a different energy, we're going to assume energy is increasing as we move this way. So any orbital that's a different energy, we're going to write it separate from one. Any orbital that's the same energy, there's a fancy scientific name for that, degenerate. We're going to write those together. Then we're going to show 3s2. We're going to show 3p6. Then we're going to show 4s2. Then we're going to show after that. And then that's going to be my 4s. Well, I need those d orbitals. So what I'm going to do, I'm going to go ahead over here. I don't need really the rest of this periodic table. I'm going to white this part out so I can continue on. And I'm going to draw all 5 of my 3d orbitals together. That's going to be 4s. That's going to be, this is 2p. This is 3s. I'm going to get rid of this energy word in here. It's going to confuse us. Here's 2p, 3s, 3p. Okay, then we start loading the electrons in. They load into the lowest energy orbital first, and then they load until they fill it up with 2, and they have to have opposite spins. So there's my opposite spins. Here's my opposite spins. Now we're going to follow Hund's rule when we get to here, which says put 1 in each orbital with the same spin, and then load up the others. So we'll do the same thing here, 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 and here. I'm going to start using a half-headed arrow just to save a little time. Now when I come over here to the D's, we're going to follow that same rule for Huns. This would be wrong. That's not good. And then, so don't do that. So we will, on this, go 1, 2, 3, 4. So that's okay. This is wrong. Or you could have done 1, 2, 3, 4. You could have said 4 downs. And they all have to be spinning the same way. This would be wrong, even though you're putting 1 in each one. They cannot do that either. So that's wrong, that's right, that's right, that's right. And by the way, also, I could give you another correct that would look like this. 1, 2, 3, 4, 5. They don't have to be right next to each other. Just as long as they're all in the same spin. We don't really know which orbital they go into. Now, we'd like to be able to shorthand this, and the shorthand notation says that we're going to go to the noble gas in the row before the element in charge. And I just blocked it here, but before chromium on the chart would be the noble gas that would be at the end of the row would be argon. So we're going to take argon, which by the way is right here. That 10, 18 electrons, 10, 18 electrons are argon's electrons. So we're going to put that in brackets. And we're going to write the remaining part of this, 4s2 3d4. Okay, so that does it for us. If I was shorthanding this to show the boxes, I would only show this box and these 5 boxes. And you can do that on worksheet 5-2. So we would just show the end part of this. We'd write argon and then just show 4 electrons. I apologize for trying to squeeze that in there. All right, the next thing we're going to do with this, let me get a new screen, is, if you will remember, it is now argon 4s2 3d4. This is chromium's electron configuration, element 24. The next thing we're going to be asked for is valence electrons on the worksheet and something called the Lewis dot diagram. Or sometimes it's just called a dot diagram, or sometimes it's just called a Lewis diagram. Valence electrons are the outer shell electrons. And remember, the numbers in front on the configuration are the shell numbers. So, that's a shell number, that's a shell number. For valence electrons, it'll always be the biggest number. It won't be necessarily the one that's written last. So 3d4 is written last, but it is not the outer shell. 4s is the outer shell. So the valence electrons here, they're going to ask you, I think, to box them on the worksheets, would be those. So in this case, the 4s electrons, 2 of them, are the valence electrons. Well, the Lewis dot diagram structure, what we're going to find out is in the next chapter, those are the ones that do chemistry. So you'll see how important it is to be able to just write these fast and find the valence electrons. Well, the Lewis dot diagram shows valence electrons as dots. In this format, we'll use a generic element called X. We're going to go 1, 2, 3, 4. We'll learn later this order doesn't matter. It just matters that you go around once with one and then back around again with the second one. So in our case, we'll take our chromium. We're going to write the formula for chromium. Don't put X. And we found out there were 2 valence electrons. So we're going to show those as 2 dots. 1, 2. It's not wrong to do this. It's not wrong to do this. It's wrong to do this. That's the only way you're going to be able to miss it if you pair them up. They just need to be 2 singles, and I don't care where you really put them. So that gives you an example of everything you need to be able to do that will allow you to finish up worksheets 5.1 and 5.2. And I'll see you guys next time.